Hello, welcome to iModeler. During this video session, we would like to demonstrate features and functionalities of our modeler by creating a simple geological profile. The details of system-specific installation are discussed in great detail in the user guide and will not be mentioned here. Regardless of your operating system, you will see this window once you launch the program. We start New Project by going to the File menu in the upper left corner and selecting option New. You can also load already existing projects and save the ones you're currently working on. Import option allows you to load an image of a geological profile as a background to reference when creating your own geological layers. We will discuss this option in another tutorial. Initiating new project enables the drawing panel, where the geological profile will be designed, and also the editing tools here on the right side. A settings menu will also pop up. Here you can specify physical characteristics of a geological cross-section, as well as computational parameters needed to simulate wave propagation. For the purpose of the computation, we define the size of the geological cross-section in terms of two parameters: number of grid points and the distance between them. So in this case, the horizontal distance of the cross-section, as well as its depth, are 2.5 kilometers, or a product of the number of grid points and the step size. Depending on what user is trying to model, he or she can select what boundary conditions they want to use for their computations. The user can also decide how the selected boundary conditions shall be mathematically represented within the program. You can choose the PML or Surgeon options for that. You can also choose what method should be used to complete the finite difference calculations by selecting either TK or TX. Detailed descriptions of each choice, as well as their computational advantages and disadvantages, can be found in the user guide. Last block in this menu is time settings. We specify that we want the wave to propagate through the layers for 3 seconds. Then, during this time, we compute wave propagation every 4 milliseconds. We save the data describing the wave propagation in the form of a snapshot every 40 milliseconds. And we start saving the data 100 milliseconds after the source has generated the wave. Here by default, we take only one snapshot, because as you can see, the time when we start recording and the time when we finish recording are the same. However, you can change that and then specify the time at which you would like to end collecting snapshots. If all the fields are filled in correctly, then the status bar at the bottom of the settings window will have a green outline and it will read, "Everything looks good." We can now proceed to creating geological profile itself. We begin by creating several geological layers using different editing tools available to us. We define a particular layer by outlining its borders, and we can do it with the pencil tool. This pencil tool creates a straight line between 2 points or nodes. To create a layer that stretches along the entire horizontal length, place your first node on the border. The node appears blue. Now continue setting nodes the way you want your layer border to be, and finish by placing the last node on the opposite border. Notice how active nodes are blue and inactive ones are green. You can also use this tool to create a closed-off impurities in your layers that are composed of different formation than the layer itself. The pencil tool is great if the border does not change much, or on the contrary, changes too sharply. Creating a curved line with the pencil tool is a more tedious task, since it would require many small straight line intervals. For this purpose, we have the smooth pencil tool, or a continuous pencil tool if you will. We start by selecting a point on the border. Then, select a point near the border, and without letting go of the mouse button, you can draw a smooth line. The modeler will periodically include nodes along this line. This tool is also very handy for drawing inclusions that may exist within certain layers. You can also delete nodes and the lines between them by clicking on the eraser icon. Once you have created the border, you can use this tool right here to move existing nodes however you want. Last but not least is, in case you want to smooth sharp edges of already created border, you can click on this icon right here. This particular tool is used to smooth sharp parts of the border. You have to select 3 consecutive points, after which you will be prompted with a menu, where by playing with 2 fitting parameters and by varying the number of points that will be used, you can select an interpolation line that will replace existing sharp segments. Last option in the editing panel is currently disabled because it has to do with the import option and requires uploaded background image. It will be discussed separately. Now that we have created the outline of geological layers, we can proceed to specifying what type of formation does each layer represent. We select the Fill panel. A warning will appear that notifies the user that he or she will not be able to manipulate the borders between layers once they are in the fill mode. This, however, does not mean that you will not be able to edit these borders at all. If there is something that you want to adjust, you can always return to the Edit panel. However, if you have filled the layer in the Drawing panel, that action will be lost. Let us begin defining types of layers that are present in this geological profile. I would like this example to be an example of a survey possibly done on the ocean, so my very first layer will represent water. By going to the Soil toolbox, I select option Add in the appeared menu. I can name the layer type according to the particular material or formation it represents. Then, define the velocity of a P and S wave propagations and the density of the material composing the layer. I can also pick what color I want to use to represent this layer type. Let the first layer type be homogeneous. The status bar at the bottom of this window will notify if you have filled all the fields correctly. I will also create another homogeneous layer, after which we will explore other possibilities. Now, let's create type of layer where the parameters such as the velocity of P and S waves, as well as density, will be varied with depths. Let us add the third layer, and after we select VP, V sub S, and Rho, let's choose Gradient tab. Here user can define by how much should the values of velocity and density change throughout the layer in the Z direction. Note that the type of fill you select will also be reflected in the little icon near the layer type in the Soil toolbox. I would like to define the fourth layer type to have a random fill. When we select Random tab, we can set A and B, which are the correlation length. We can also specify the standard deviation for each parameter and the type of filter we will use to generate randomness. The two types of distribution are Laplacian and Gaussian, with the choice of exponential factor L for the Gaussian filter. Exact mathematical formulas for these functions are given in the user manual. After this layer type, I would like to generate two more. We do not particularly care for the reality of this particular geological profile, and I will use somewhat random numbers just to make different types of layers. We are ready to complete our geological profile. To do so, click on the Paint can and then pick a layer that you would like to assign particular layer type to in the Drawing panel. When you click on the gray area, it will be filled with the color corresponding to the layer type you selected. Note that gradient and random fills will take longer to process. Here, I would like to bring your attention to two things. Notice how here I have left one layer border incomplete. I have not connected it to the border of the Drawing panel. When I try to fill this layer, the program will also fill the layer next to it because they're not completely separate. In order to fix the border, I need to return to the Edit mode. When you click the Edit tab, you will be prompted by another warning. It means that anything that you filled on the drawing panel will be erased. However, all your layer types that you have in the panel on the right will still be there. Now, if I go back to the Fill mode, I will be prompted with the warning we have seen earlier. If the user needs to do a lot of back and forth editing while creating the profile, he or she can go to the Edit menu in the upper left and select option to disable warnings between stages. I will go over the other options in this menu in a few moments. For now, let us return to the Fill mode and assign the layer types to these layers. Our geological profile is practically complete. This is, however, not everything that we need to include. If we want to simulate geophysical survey, we need to place and specify our sources and indicate where we would like to have our signal receivers. This is what the first two icons right here are for. Let's start with sources, which have the explosion icon. Select the icon and click where you would like to place the source. Once you have selected the location, you will be prompted with a menu that allows you to modify X and Z coordinates of the source. It is also possible to select source type in the form of the wavelet generated by this source. This panel right here shows the graph of the chosen wavelet, and depending on the signature chosen, you can specify certain parameters, such as maximum frequency and so on. You can also define an array of sources. Simply click on the drawing panel where you would like to place the first source and drag the mouse to where your last source will be. Once you're done, a similar menu will appear where you can adjust coordinates of the first and the last source in the array. The sources will be placed equidistantly from each other along the line you have created. And you can also define how many sources you would like there to be. You can also select the multi-shooting option if you would like each source to go off at different times, or you can specify strengths of the generated wave from each of the sources. Once we're done defining the sources, we can now place receivers. Receiver icon is the one that has a black circle on it. Simply select this icon and click on the drawing panel where you would like the receivers to be. Here the receiver menu is simple. It allows you to correct the coordinates of the receivers. You can similarly create an array of receivers. Note that there are two status bars at the bottom of the screen. One indicates the status of the profile creation. Another, a smaller one, shows the coordinates of the mouse pointer on the drawing panel. This should give user a perception in space while creating the geological profile. This is a good opportunity to look through the options in the Edit menu. The Show Grid option reveals the grid of points that will be used in the computations of the wave propagation. If you have defined sources or receivers in another file, you can upload it to this geological profile. You can also save a file that will contain information on the sources and receivers. It will include their positions, as well as the information about the sources and the wavelets they generate. If you have used the image of an existing geological profile, you can hide it at any point if it gets in the way of your editing. As was mentioned earlier, if you have to do a lot of back and forth editing, you can disable the warnings that appear when you go from one stage to another. You can also bring back the settings menu, which we had when we started the project. There, you can modify computational settings as well as edit the grid you're working with. Last option clears off the drawing panel. The next menu, the Mode menu, will allow you to view results once you have performed the computations. Help menu contains information about iModeler and its developers, and the link to the user guide. Now that we're completely done with our geological profile, we can save our project and send it to the server to perform calculations. In order to do so, first take a look above the drawing panel. You will see a white field with a magnifying glass icon left to it. Once you click on it, it will allow you to pick a directory where you would like to save your project. Once this is done, you should choose Save tab on the right side. Clicking on the icon with a computer monitor on it will save your project to the directory that you have just selected. Saving includes settings data, information on sources and receivers, information on each layer and its composition, and the image of your geological profile. Another important note: there can be several source objects, but there cannot be several receiver objects. What that means is that when you create receivers, you can either create a single receiver or you can create an array of receivers, but not both. At the same time, you can have a single source and then a separate array of sources. In order to proceed to computations, after saving, you should click the play button. We will leave the discussion of computations and results for the next video session. We hope that this tutorial was helpful. If you have any questions, please feel free to contact us at the email that you can find by going to Help, About. Thank you for choosing iModeler.